Bismillahirrahmanirrahim. Welcome to MIT. Today we are going to learn differentiation. And for learning differentiation, many a times we learn the formulas and concepts. Actually, according to my opinion, only learning the formulae doesn't benefit us perfectly. So, for more perfection, we should apply the rules practically. Whenever we solve the problems applying the formulae, it is more convenient and more everlasting in our mind. That's why I always prefer practicing the problems, solving the problems rather than explaining the formulae. Formulae is the fundamental part, but learning only the formulae cannot make us perfect. That's why I always prefer solving the problems practically. Let's move on to the first question. Today's question, first question belongs to paper 0606 slash 13, session May June 2024. The first question we have chosen from this paper is question number 3A. Let me show you the question, zooming it out. The question number 3 is find the coordinates of the stationary points on the curve y is equal to 2x plus 1 whole square into x minus 3. So, whenever we are given any question like this stationary points, look, stationary point means indirectly they tell us to find the derivative, means differentiation. So, we are going to differentiate the quantity 3x plus 1 whole square into x minus 3, and you can see that I have already solved, means I have already written the solution over here, because if I write and simultaneously explain the points, then it will be lengthier, the size of the video will be lengthier, which will be the wastage of your precious time. So to save your precious moments, I have just already written. Now I am going to explain and clarify the points which are needed to be. Let's start writing the solution. First y equal to this, then we have written dy over dx. Looks, derivative should be written, this is the notation for derivative or differentiation, dy over dx. Then this is actually, there are two functions. Look, first one is the quadratic function, second one is the linear function. So first of all, we should know if the two functions are given and they are in multiplying state. This is called actually product rule of differentiation. So we are going to know how to differentiate the two functions which are in multiplication state. So let's learn product rule of differentiation. So we are starting learning our differentiation class with product rule. Let's see, there are two functions like x and y, or we can call them as u and v. So dy over dx of u and v, two functions. First function is u, second one is v. So how to start this? Always we will write the second function first. Look, this is the first rule. Second function should be written first, then we will write d over dx of u, then plus, for multiplication we will use plus symbol, for division if the functions are in dividing state or denominator or fractional state, then subtraction. So this is in multiplication state, so we will use plus symbol. Then we will write we have started with v. Look at this. First of all, this is the key point for starting of the product rule. Always we will start with the second function. So second function is v. After v we will write d over dx of u, first function. Then again we will start with the first function, then d over dx of v. So how did we start? First, the second function should be written. Always the second function. Remember, second function should be written first. Then derivative of the first function. After that, plus symbol for multiplication. Then first function. and derivative of second function. So key rule is second function should be written first of all. Always we will write the second function, then derivative of the first function. After that, it's just vice versa. We have started with second function. In the second case, we will start with the first function, and definitely the next function should be differentiated. That means d over dx of v. So first we started with the second function, then derivative of the first function. After that, we started with first function, then derivative of the second function. Now let's see what should be the differentiation of these two functions. Let me erase this rough work. Our first function is 2x plus 1 whole square. So 2x plus 1 whole square. First of all, remember here the key point is always we will look at the exponent. Whether this is inner function or outer function, whatever, we always look at the exponent. Here exponent is 2. First of all, we will write 2. Then we will differentiate the inner function. First, what did we do? We have looked at the whole of the function, composite function. Then we have looked at the inner function. In inner function there is 2x. Okay, so 2x means what is the exponent of x? Exponent of x is 1. So we know first of all we will have to write this one. Okay, then this constant, that means this exponent will multiply this constant, and the degree of variable x will be reduced by 1. It is the degree of x is 1. If we subtract 1 from 1, then it is going to be 0. So ultimately it is going to be 2x 0, means 2x 0, x raised to 0 means 1, so it's 2. That means the derivative of 2x is actually 2. Once again I am repeating, first of all we will look at the exponent. This is the exponent. Exponent is 1. Then this one will multiply the coefficient. So we have multiplied 1 and 2. After that, the degree or exponent of the variable always will be reduced by 1. So here degree is given 1 or exponent is 1. From 1 we have subtracted another 1. Always 1 should be subtracted. So the key point of differentiation is the exponent. Always in case of derivative, always the exponent will be reduced by 1. So from 1 if we subtract 1, it gets 0. So x raised to 0 means actually 1. So we have got that the derivative of 2x is actually 2. Once again we are going back to the whole function. So as the key point for derivative is always the exponent, look at this, exponent should be written at the beginning for multiplication. So we have written these two for multiplying. Then we have looked at the inner function. In the inner function it's 2x. We have already shown that the derivative of 2x is 2. So we are writing this 2. After that we will write the function, whole function, 2x plus 1. I have already told that the exponent is always reduced by 1. Exponent will be reduced by 1. So from 2 if we subtract 1, it is going to be 1. That means this is going to be ultimately 4 into 2x plus 1. Let me write this below this after erasing this, equal to 4 into 2x plus 1. Well, this is the derivative of the first function. Now let's talk about the second function. Our second function is what? Second function is x minus 3. X minus 3. Well, once again we are repeating the same step. Here the exponent is 1. Look, the degree is 1, so 1 will be over here. Then this function should be written. Before writing this function, we will just look at the inner function. In the inner function there is x, and degree of x is 1, so 1 has already been written there, and exponent will be reduced by 1. Here degree of x is what? Degree of x is 1, here 1. So we will write x raised to 1 minus 1. Always the exponent is reduced by 1. Now the question is about 3. This 3 is a constant number. Remember, the derivative of any number, any constant number is 0. Okay, so it's plus 0, which doesn't make any difference, so we are avoiding writing this 0. Okay, so what are we going to get? 1 into x raised to 1 minus 1, and the function, remember, the given function must remain unchanged, x minus 3. Okay, what will happen to the exponent? Exponent is 1 minus 1 means 0. So one thing is very sure, every time we are repeating, I'm repeating the same word, that exponent will be reduced by 1. Whatever exponent is given, it will be reduced by 1. Always we will subtract 1 from the given exponent. So ultimately what are we going to get? X raised to 0 into, here also exponent is 0. When exponent is 0, it's actually 1. Exponent of 0 is 1. So here also exponent is 0. X raised to 0 is 1, and 1 is equal to 1. It's actually 1. So derivative of x minus 3 is 1. Okay, so what have we done? First we have found the exponent, derivative of 2x plus 1 whole square. How did we get this? We have just written the exponent. Once again I am repeating the same step. We have written the exponent. Exponent is 2. Then from the inner function, we will find the derivative. So inner function, how to find derivative of 2x is 2. Already I have shown in the previous few minutes, a few seconds ago. After that, the whole function will be written, and the degree, always exponent, this is actually the word which is being repeated multiple times. Exponent will be reduced by 1. So from 2, if we subtract 1, it will be 1. So for 2x plus 1 whole square, we have got the derivative of 2x plus 1 whole square is 4 into 2x plus 1, and the derivative of x minus 3, same goes here, x raised to 1. Here if we subtract 1 from 1, it is going to be 0. X raised to 0 means 1, and whole function, about the whole function, the degree is 1, exponent is 1. From 1, if we subtract 1, it will be 0. So any number containing 0 as exponent is 1. So 1 into 1 means 1. And if there is any, here also there was a constant number 1, derivative of 1 is actually 0, so we don't need to add or subtract 0. Here also derivative of this number, integral number or any number, any constant number produces 0 as the derivative. So if we add up 0, it will be actually 1 plus 0 means 0. So what have we got? Derivative of 2x plus 1 whole square is equal to 4 into 2x plus 1, and derivative of x minus 3 is 1. Let's go back to our major solution. Once again, I am repeating how to write, how to solve the derivative of two functions which are in multiplying state, that means product rule. This is simply called product rule of derivative or differentiation. So first of all, always we will write the second function. We have written the second function, then the derivative of the first function. This was the first function, so second function into derivative of the first function, plus vice versa, first function into derivative of the second function. Then here look at this, first of all we will differentiate this one. This portion should be differentiated. We have already shown in the, just beside this, the derivative of 2x plus 1 whole square is 2 into 2 2x plus 1. That means if I am to repeat the same words, it will be this 2, this 2 is the exponent. Exponent has been written first, then the inner function, the derivative of 2x is 2, then the whole function has been written, and the exponent of the function was, whole function was 2. If we subtract 1 from 2, it will be 1. Over here it will be 1. Then the second function, we are not finding the derivative of this. Look, second function will remain unchanged, so we left it unchanged. Same goes, the same step will be repeated for the next part also. We will first differentiate this from the previous explanation you have come to know that the derivative of x minus 3 is 1. So we have written here 1. Then this function will remain unchanged because we don't find the derivative of the first function. So first function is unchanged. After that, what are we going to get? It's 2 2s are 4. Then as this is in multiplying state, we are going to multiply 2x into x, 2x square, 2x into 3, negative 6x, 1 plus x, x, and negative 3, positive 3, positive 1, it's negative 3. After that, this is a plus b whole square. You know how to apply the formula of a plus b whole square. So a square plus 2ab plus b square. If we simplify this, we are going to get 4 2s are 8 and 4 6s are 20. That means not 20. I have written it simplified form. Negative 6 plus x means positive 5x. Sorry, negative 5x. So negative 5 and 4. 4 5s are 20. Okay. Then 3, negative 3 and 4. So negative 3, 4, 3 fours are 12. Negative 12. Then this is as it was. After that, last of all, we are going to simplify this. 8x square plus 4x square means 12x square. Then 20x minus 4x means 16, negative 16x. Then negative 12 and positive 1 means negative 11. So we have got d over dx is equal to 12x square minus 16x minus 1. So what have we learned initially? It is all about the exponent. Exponent is reduced by 1. Always the degree is reduced by 1. That is the key point, major point, or a root concept of differentiation. So don't forget this. We will repeat the same steps again and again whenever we solve the derivative problems or differentiation. The exponent will be reduced by 1. This is the number one concept or point. Let's see what the next question we are going to solve. I have chosen the next question from paper 060624, question paper 12. That means this is question paper 12 of the question number 12 of paper 0606. Look, you can see over here, it is paper 0606, question paper 12, and question number 8. The question 8 says y is a curve has equation y equal to 3x square minus 5 over 1 over 3 divided by x plus 4. Let us solve both of the numerator and denominator. We are going to find the derivative of first the numerator and then the denominator. Let us consider the upper function or numerator as u. So we are going to find the derivative of u du over dx. Okay. So I think you have not forgotten that first of all we write the exponent. Exponent is 1 over 3. Then the inner function should be differentiated. If we differentiate the inner function, always the exponent multiplies the coefficient. Here exponent is 2 and coefficient is 3. So we will multiply by 3. I mean 3 2s are 6. Okay. So this is all about the exponents. Then what will happen? The inner function will remain as it is. No, still we will have to look at the inner function is 6. But what about x? There is x also. The degree of x or exponent of x will be reduced by 1. Here degree was 2. Now if we subtract 1 from 2, it will be 1. Let's talk about the inner function. Then inner function will remain unchanged. Then what about the exponent? Exponent of the function is always reduced by 1. If we subtract 1 from 1/3, what is it going to be? So 3 2s are 6. So it is 2x, then thrice x square minus 5. If we subtract, it is going to be 2 over 3. So what have we done? It's all the same actually. If you were attentive in the previous case, you will understand it very easily. That first we write the exponent. Here exponent is 1/3. We have written here. After that, we differentiate the inner function. Inner function is 3x square. It was 3x square. So exponent, always exponent is the word which is being repeated maximum times. So you should not forget and you should not make any mistake in case of this. Always the exponent is the key role player in derivatives. So we have written 2. If we write here 2, then this 2 will multiply this 3, exponent will multiply the coefficient. 2 3 is 6. Then what about the variables? So we cannot ignore the variables because we are differentiating the variable, differentiating the function with respect to x or variable. So variable should not be ignored. Always we will look at the exponent of the variable. So here exponent of the variable was 2. Well, if we subtract 1 from 2, it is going to be only x, I mean x raised to 1. Then the inner function should remain unchanged and the exponent is always reduced by 1. So ultimately what did we get? The derivative of this one, derivative of 3x minus 5 raised to 1 over 3 is 2x into 3x square minus 5 raised to negative 2 over 3. Let's differentiate the second function. It was the first function u. Our second function, let the second function be supposed to be v. Okay, second function v, and it is actually x plus 4. We are going to differentiate x plus 4. So let's write derivative of b is equal to the same word, that exponent of x is actually here 1. So we will write here 1. Then the what will happen to the inner function is our x plus 4. Okay, x plus 4. Then whole of this actually, or we can do differentiate this is individually. Let us differentiate only x, because we know the derivative of any constant number is 0, so we don't bother about this one. This is constant number, it will be 0, it will not make any difference. Just we will differentiate x. So exponent of x is 1, we are writing 1. Then what happens to this x raised to degree is 1, so if it is reduced by 1, it is going to be x raised to 0. And if the exponent is 0 on any number, it is actually 1. So exponent derivative of x plus 4 is actually 1. Let's go back to our solution, main solution. In the previous solution, we learnt the product rule of differentiation. Now we are going to know the quotient rule of differentiation. Quotient means there will be a fraction. How to do that one? Suppose a function is dy over dx. We do have a function like this, d over dx of two functions. One is u, another one is v. This is called quotient rule. If you find fraction, then you will apply the quotient rule. How to write this? It's actually always the first, the second, I mean denominator, the second function should be written first, then the derivative of d over dx of your first function, then minus. In previous case we did multiplication, that's why we used plus symbol. As this is difference, I mean denominator or division, that's why we will use subtraction symbol, I mean minus symbol. Then it will be v, then d over dx of u, d over dx of u. So how to do this? Always we start with the second function, okay, or denominator, then second function into derivative of the first function, minus first function, sorry, this is actually u, which looks like v. So we start with the second function, then the derivative of the first function. After that we write the first function, then the derivative of the second function. You may remember in the previous one also, for product rule we always write the second function. Whether this is product rule or quotient rule, every time we will write the second function first, second function into derivative of the first function, and first function into derivative of the second function. Just the difference between quotient rule and product rule is this symbol. In between them, the symbol will be minus if it is quotient rule, means if it is a fraction. If it is not a fraction in multiplying state, then this will be plus symbol. So what have we done here? The second function, our second function is this, x plus 4. We have written x plus 4. Then the derivative of the first function, means the upper function. After that, minus symbol for quotient rule, we have just explained here. Then first function, upper function into derivative of the lower function, means we started with the second function and ended with the first function. I mean, we started with the second function and ended with also the second function. Second function should be written on top. Then the denominator, I mean the derivative of the first function, then minus first function into derivative of the second function. And remember, in case of product rule, actually there was no denominator, but in case of quotient rule, there is a fraction. Always the denominator will be square of the given function. The function is x plus 4, so we have written x plus 4 whole square. So this is for extra part for quotient rule, that the denominator will be whole square. Well, then we have differentiated this portion. First of all, we are going to differentiate this. Already I have differentiated both the functions numerator as well as denominator. Again, I am going to repeat the step in brief, that first we will differentiate this function. Okay, this one is the exponent is 1/3. Then if we differentiate the inner function, 2 3s are 6, this 2 3s are 6, and the variable will be x, and if exponent is reduced by 1, 2 minus 1, it is 1. Okay, after that, inner function will remain unchanged as it is. Then the degree will be reduced by 1, so from 1/3, if we subtract 1, it is going to be negative 2 over 3. And the first function, as we are doing nothing to this, it is not to be differentiated, it will remain unchanged, so we have left it unchanged. In the next case, this function will remain unchanged. First function is unchanged. We will have to find the derivative of the second function. Already I have explained, taking much time, that the derivative of x plus 4 is actually 1, this one, means derivative of x is 1, means exponent is 1, so we have written 1. And the variable will be x raised to 1 minus 1, means 1. X minus 1 minus x raised to 1 minus 1 means x raised to 0, means 1. And the derivative of constant number 4, it's 0, so 1 plus 0 means 1. And this function will remain unchanged. Let's do the calculate. The rest part is actually algebraic simplification, and we can see that here our degree is negative. Look, whenever something is negative, it is actually denominator. Suppose here it is written 5x raised to negative 2. All of you are acquainted with this, yet I am writing. What will it happen? Whenever exponent is negative, it goes down. Actually, this is denominator x square, and 5 is numerator, because 5 doesn't have any negative or inverse exponent, so 5 over x square. That means whenever we find 5x raised to negative 2, this is 5 over x square. Same goes for this one also. Here exponent is negative 2 over 3, and the function is 3x square minus 5. So as the exponent is negative, it will go down, 3x square minus 5 raised to 2 over 3. And here if we cancel out this 3, this 6 by 3, it is going to be 2. We can write here 2, so it's 2x into x plus 2x into x plus 4, this x plus 4, this x plus 4, 2x into x plus 4 over this one. Already I have explained, this portion is the denominator, and the third portion, it is actually unchanged, negative 3x square minus 5 raised to 1 over 3. It has remained unchanged. After that, what are we going to write? Let us look at the sidewise. I have written it just at the right side. So this function should be, this is a composite function. First of all, we are going to simplify whole of this numerator. Okay, not this way, let me show you more appropriately. From here to here, this is our numerator. So the exponent, I mean the denominator is this. So by the same denominator, if we divide, it will remain same. So 2x square plus 8x, first function, minus this minus symbol, this minus, then the second one, look at this 3 2 here. Exponents are 2 over 3 plus 1 over 3. It's actually 3 over 3. 3 over 3. 3 over 3 means 1. That means if we multiply this function as well as this function, they will produce actually 1. Exponent will be 1. The function, you know that x raised to 2 over 3, if you multiply this into x raised to 1 over 3, this is actually x, and for multiplication of this exponent is actually 1, I have shown. So x raised to 1, that means this function will be only this function will be written. So we have written only the this function, and exponent is 1. And this is algebraic calculation, addition, subtraction, you know it very well. Well, the denominator is unchanged. Okay, after that what have we done? After that we have written here 2x square plus 8x. If we simplify the symbols, 3x square plus 5, then denominator is unchanged. The second denominator, I mean the denominator is unchanged here. And if we simplify, look at this, the first function, if there is composite function, the first function will remain unchanged. Look at this, it has remained unchanged. 2x square, negative 3x square plus 2x square. If we subtract 2 from 1, it is negative x square. Then 8x unchanged, then positive 5 is also unchanged. And what will happen to this denominator, as it is this denominator, and this one is also denominator, this one is also denominator. You know how to do this. If we write x over y over z, okay, and this is the line of equation, how will we write? We will write x over y, then this z will go down. This is numerator in the lower function, but it will go down. This is how we can write a composite function in simplified form. Now let's see what did the question tell us to do. If we go back, we will find the question is actually, they have told us to write in this is the function. Okay, let me erase this part. They told us to leave the answer at this stage. Okay, so what is this stage? This is first a x squared, a x squared plus bx plus c. Let's see what is our a x squared plus bx. That means beside x squared there will be a, beside x there will be b, and c is a constant number. The denominator is 3x squared minus 5 raised to 2 over 3 into x plus 4 whole square. We have also written in this format. Let's see our solution. Our solution is this. Here we have written that x square, negative x square plus 8x plus 5. So a is negative 1 and b is 8 and c is our 5. And the denominator, they have told it should leave at this stage 3x square minus 5 raised to 2 over 3 into x plus 4 whole square. So we have completed our solution as per the instruction. Let's start with the next solution. We are still under the same question. This question says, hence find the x coordinate. This is question number B actually. This is B. B says, hence find the x coordinates of the stationary points on the curve. Give you answer in their simplest exact form. That means they have told us to find the stationary point first, and in initially we have got the derivative of this function. This is actually a related question. Whenever derivative is found, then in most cases question asks for finding the stationary point. Actually stationary point means the derivative will be 0. After differentiation, whatever we get as derivative, that will be equal to 0. So here also same question, it says find the stationary point. Stationary point means here stationary point, whenever stationary point, the word stationary point mentioned, then derivative will be 0. So we have written dy over dx is equal to 0, and dy over dx in the previous solution we have shown that d over dy over dx is actually this. Okay, from the previous question we have copied this. After this, if we do cross multiplication, what will happen? Here look, cross multiplication means under this 0 there is 1, then we will multiply, 1 will multiply this, and the denominator will multiply by 0. So by 1, if we multiply the numerator, it will be x square plus 8x plus 5 equal to 0, because if anything or any quantity is multiplied by 0, it is going to be 0. So right side is 0. Then as there is a negative symbol in front of the first leading quantity, then we have dissolved this symbol. Every symbol has been simplified. If you simplify the first symbol, first one is going to be plus, first one is plus, second one was plus, it is going to be negative, third one is given plus, it is going to be also negative. As this symbol is positive, so it is going to be actually negative, it is not positive at all, it is going to be negative. Let me erase this symbol. This one will be negative symbol. Okay, after that this is a quadratic equation, you can say that is x square. So you know how to apply the quadratic equation for finding root. X is equal to negative b. Negative b is actually in negative 8, means negative negative positive, so minus minus positive, so this is plus 8, then plus minus square root over b square. B is negative 8, so b square is 8 square plus 4ac. 4ac, c is having negative symbol, so it is going to be 4ac. Here there was a minus symbol, and in front of c also minus symbol, it is going to be plus. After that, what are we going to get? X is equal to 8 plus minus square root over 8 square means 64. 64 plus 20, 84. Then here square root of 81, this 81 can be written as 4 into 21, 4 into 21, and square root of 4 is 2. That's why we have written, instead of 8 square root over 84, we have written 2 square root over 21. Then we can divide each of the quantities by 2. If we divide 4 by 2, if we divide 8 by 2, it is going to be 4. If we divide 2 by 2, it is going to be 1. And if we divide 20, these 2 divided by, if we divide this 2 by 2, it is going to be 1. So this is actually our ultimate answer, because let's go back to the question. What does the question say? The question says that here, this is the question, find the, this is our question, find the x coordinate. They have told us to find the value of x, and this is our value of x we have obtained. They didn't tell us to find the y coordinate, only they have told find the x coordinate. So we have got this, this is our ultimate answer. Let's talk about the next solution. The next question has been taken from this one. This is you know, 06 11 May June 24. That means from the paper 11 of 0606 means add maths, we have taken this question. So let's read the question. The question says, it is given that y is equal to ln 3x over x square for x is greater than 0. Find dy over dx, means they have told us to find the derivative, means we will differentiate this. How to differentiate this? We are going to write this differentiation. Let me write just beside this. Let's consider our first function, u is equal to ln 3x. So we are going to differentiate du over dx is equal to, so remember, whenever ln function is given, we don't look at the ln. For finding derivative of ln function, we don't look at ln, we just differentiate the inner function of that ln. So here, except ln, there is 3x, the exponent is 1. Okay, so 1 into 3, and what will happen to x? The degree of x is going to be reduced by 1. 1 minus 1, 1 is the exponent, and it will be subtracted from 1. And the denominator, look, the denominator will be the function. The function is thrice x. So what have we learned? In case of ln function, we will not look at ln, we will differentiate the function, inner function, and that will be the numerator. That will be the numerator, and denominator will be the inner function as it is. So what have we got? It is going to be 3x over 3x, means that is, no, this is not 3x, it's actually x raised to 1 minus 1, means 3 raised to x. So if 3 is dissolved and x raised to 1 is 1 and denominator is x. So if we simplify ln 3x, it is getting 1 over x. So how to do this? Once again, I am explaining it briefly, that the function, the only the inner function will be differentiated, then the function itself will be written as the denominator. After doing so, we have got 1 over x. Let's talk about v. The second function is x square. So dv over dx is equal to the exponent. Always the exponents come first, and then that is x. The degree will be reduced by 1, I mean exponent will be reduced by 1, so it is going to be 2x. 2 minus 1 is 1. So the derivative of 2x square is, I mean x square is 2x. Let's go back to our solution. If I repeat this step again, look at this, the derivative of ln 3x is actually 3 over 3 over 3x, 3 over 3x. Then this x square, this x square is not denominator at all, so this is numerator. So we have written 3x square minus 3x square over 3x. Then in the second derivative, we got the derivative of x square is 2x. So we have written here 2x, and ln 3x will remain unchanged because we are not finding the derivative of the first function. After that, it is going to be denominator is x raised to 4. In numerator, after simplification, we get only x minus 2x into ln 3x. Now, if we go downward, we can see that here everybody can be divided by x. If this is divided by x, it will be 1. If 2x is divided by x, it is going to be 2. And ln 3x, remember ln 3x is inner function, it cannot be touched at all. And if x square is divided by x, it is x cube. So ultimately what have we got? That dy over dx is equal to 1 minus 2 ln x over x cube. And they have told us to find, let's see, they have told us to find the dy over dx, and we have got that dy over dx is this. So that is our answer. Let's start the next solution. This question belongs to paper 9709 slash 13 May June 24. That means this is an A level question paper of pure maths 1, paper 13. Paper is 13 May June 2024. Well, the question says the equation of a curve is y equal to 2x square minus 1 over 2x plus 3. Well, find the coordinates of the stationary point. You may remember that whenever stationary point, the word stationary point mentioned, we find the derivative is equal to 0. So we will have to find derivative. Let's start the solution. Y equal to 2x square minus 1 over 2x plus 3. This is our y. Then dy over dx is equal to, look at this, you know the derivative of 2x square. 2x square, look, this will be over here. So 4, and exponent of x will be reduced by 1, that is it will be 1, means 4x. So we have written that the derivative of 2x square is 4x. then 1 over 2x. Let's find the derivative of 1 over 2x. It's a little bit more complicated. So derivative of d over dx of 1 by 2x. It's actually, look, it can be written rather this way. Look, half is here. What about, sorry, half, it is half. Okay, what about this x? X is looked as the denominator, means the exponent is negative. We should not ignore the exponent, because in derivative and integration, in differentiation and integration, actually the role is played by the exponent. So here exponent is negative, as x is denominator, so exponent of x is negative. The exponent of a denominator is always negative. So how will we solve this? This is actually, this one will multiply the coefficient. So half into negative 1, it is going to be negative half. Then what will happen? X, we know that the exponent is always subtracted, it is reduced by 1. So we are subtracting 1 from the denominator. Look, this one is already there, then we will have to subtract 1. Always exponent is reduced by 1, so we have just subtracted 1 from the given exponent. So it is going to be negative half, and the exponent of x is going to be negative 2. Then whenever exponent is negative, it means it is going to be denominator. That means x negative 2 means x is the denominator. Denominator. So ultimately what have we got? That the derivative of 1 over 2x is negative 1 over 2x square. That is what we have written here. Look at this, that negative 1 over 2x is equal to negative 1 over 2x square. Now the question is, how has it become positive? Already there is a negative symbol. Look, this negative symbol, and for derivative one more negative symbol, that's why it has become now positive, 1 over 2x square. Well, they told us to find the stationary point. The question is about finding stationary point. So for stationary point, in the previous question we have solved and written that for stationary point it will be either maximum or minimum point. For stationary point, derivative is 0. Derivative is 0, we have written. So this is a term or phrase which you can memorize, that whenever stationary point word mentioned, then you will find derivative and derivative will be 0. So we have written, for stationary point derivative is 0. So what was our derivative? Our derivative was 4x plus 1 over 2x square. 4x plus means this one. This one is our derivative. 4x plus 1 over 2x square is equal to 0. Then at the right side, if we look at this, 4x plus 1 by 2x square, if we simplify, 4 2s are 8. 4 2s are 8, and x, if it is multiplied, it will be x cube, then plus 1 will remain unchanged, then denominator is also unchanged, right side is 0. After that, what will we do? We will do cross multiplication. After 1, under 1 there is, under 0 there is 1, so if we do cross multiplication, it will remain same, and if 0 multiplies the denominator, it is 0. So left side is 8x cube plus 1 is equal to 0. If this 1 is shifted to the right side, it will be negative 1. Ultimately, what are we going to get? Our x cube is equal to negative 1 over 8. And we know the cubic root of 8 is 2. And cubic root of negative symbol is also negative. So x is equal to, actually, we are going to get negative half. So this is the x coordinate. Actually, if we look at the question, this is the question. The question says, find the stationary point. They didn't tell us to find only x coordinate. In the previous one, we got only x coordinate, but this one says that find, once again I am showing, find the stationary point. So stationary point means both the x and y coordinates. Already we have got the x coordinate is negative half. Now we will just substitute this value to obtain corresponding value of y. Let's see what is the corresponding value of y when x is equal to negative half. x is equal to negative half. We have written here x is equal to negative half when y equal to this was our function. Our function was 2x square minus, if I show you back, then it is going to be, look here, it is, this was our original function, that is 2x square, 2x square minus 1 over 2, 2x square, x means this, minus minus 2 into 1 over 2 into x plus 3, a constant number. So if we zoom it out, negative square means positive, it has become positive actually now. So it's 2, this 2 over 4, this is 1, half square means 1 over 4, and this negative symbol and this negative symbol, it produces plus symbol, so plus 1, and these 2 will reduce this 2, then it is 1, and the third term is 3. So ultimately what are we going to get? 4, that means it is 2 over 9, because 2 plus 4, if I show you in extended form, it is actually 4, 2 plus 4 plus 6, so it is going to be not 6, it's going to be 12 actually. Okay, so 12 plus 4, 16, 16 plus 2, 18. 18 over 4 means 9 over 2. 18 over 4, if we divide both of them by 2, it is going to be 9 over 2. So x coordinate we have already obtained, half, negative half. Negative half means actually 0.5, negative 0.5, and 18 over 4 means 4.5. They have told us to find the stationary point. We have found the stationary point as negative half and 4.5. So what is the summary of this solution? Whenever we are called to find the stationary point, first of all we will find the derivative, and the derivative will be equal to 0. When derivative is equal to 0, we will obtain the x coordinate. Then substituting x coordinate in the function, we get the y coordinate, corresponding y coordinate. That is what the stationary point of this question. What does the next question say? Question number B says, determine the nature of the this stationary point. Already we have obtained the stationary point is negative half and 4.5, and they told to find the nature of the stationary point. So this is one of the new concepts to be learned. Whenever they ask for the nature of the stationary point, whether this is minimum or maximum, how can we do? We will have to find the second derivative. Already we have found, we have differentiated and found the first derivative, that is this one. We have written first derivative is dy over dx is equal to 4x plus 1 over 2x square. From in the first previous solution we have written this, that the derivative or differentiation of y is actually this. Then in this question we will differentiate this quantity once again. So second derivative, how to write this? We will write d square y over dx square. Don't write dy square, it's d square y over dx square of the function. Okay, we are supposing this to be the function. Okay, the exponent of if we find the derivative of this, look at this, exponent is 1. So if we multiply 1 and 4, it is going to be 4, and degree of x is 1. From 1, if we subtract 1, it will be 0, means there will be no variable. What about the second one? Let's do the second one. Let me show you. D over dx of our function is 1 over 2x square. Well, it can be written in the previous solution also, you may remember we did, it can be written as d over dx of half, and this x square is actually, look at this degree of x is actually negative. Whenever something is denominator, the degree is negative, x negative 2. Okay, so if we simplify, if we differentiate, negative 2 will multiply this, so it is negative half. And what will happen to this degree of x? Exponent of x is going to be negative 2 minus 1. Always we subtract 1 from that. Then it is going to be what? Negative half over x negative 3. So whenever degree is negative, it is actually denominator. Okay, here it is going to be negative 2, negative 1 means 3, so negative 3. Whenever the exponent is negative, that is the quantity will be the denominator. So ultimately what have we got? Oh, there is 2 also over here. So we have got that the derivative of 1 over 2 x square is negative 1 over 2 into 2 x cube. So that is what we have written here. Look, first of all, this 2 is negative degree. Whenever a term is denominator, then exponent is negative, so we have written negative 2. Then this 2 is a constant, is not to be changed, this 2 is unchanged, and degree of x is negative 3. So negative 3 means this is denominator. Here I have shown that negative 3. So ultimately what are we going to get? It is 4, then positive negative, it is going to be negative 1 over this 2 can dissolve this 2, so it is 1 over x cube. This is our second derivative. Okay, now we will see substituting the value of x in this second derivative. If it is more than 0, then that is minimum point. If it is less than 0, then that is maximum point. Let's see. X is equal to negative half when d square over dx square. D square over dx square, just we have found that 4 minus 1 over, let me show you clearly. This is our, this was, look, this was our d square y over dx square. So this is 4 minus 1 over x cube. 1 over x cube. X is actually our, the value of x is negative half. We are going to substitute this. So negative half cube. Then it is become 4, and this negative and this negative, it is positive. 1 over 1 cube means 1, and 2 cube means actually 8. So 4 plus, it is actually 4 plus, 1 over the second function is inverted, so it is going to be 1. So ultimately 4 plus 8, 4 plus 8 means 12. So as the second derivative, or d square y over dx squared is more than 0, this is actually minimum point. Let me show you how to write this. We will write, since d square y over d square x is greater than 0, stationary point. Where, what were the points, corresponding points when x is equal to negative half? We have already obtained in the previous solution to b, that y coordinate is 9. When the point is negative half and 9 over 2, then this is minimum. So how to know whether the stationary point is maximum or minimum? If d square over d square over y d square y over dx square is greater than 0, then it is minimum. If it is less than 0, then maximum. So this is the 2 point. If second derivative d square y over dx square is less than 0, then it is maximum. If it is greater than 0, then it will be minimum. So here we have got the value d square y over dx square is 12, which is more than 0. That means this is minimum. So the curve will look like this. When it is minimum, how will the curve look like? The curve will look like this. Okay, this way, or if we this way. So this is actually minimum point is over here. This is our stationary point. So I am thankful and grateful to you all for being patient and to have got it, listened to it very patiently. If my efforts make any benefit or causes any benefit to you, then please pray to the Almighty God for my betterment, so that I can be blessed more and more in the future days. Allah Hafiz. Thank you all.